In this lesson, we're going to develop a demonstration application, or demo app, that gives a high-level overview of what a Rails application looks like. Among other things, we'll actually build a small toy, but nevertheless quite real, database-backed web application. We're going to use a technique called scaffold generators that I do not in general recommend, but it will give us a nice shortcut to developing the basic functionality. We'll also take a look at the URLs, or sometimes called URIs, the Uniform Resource Identifiers, associated with the standard Rails application, which will give us the first introduction to something called the REST architecture. The application we're going to be making is a first step toward the full sample application that we'll start in the next lesson. In particular, it's a minimalist Twitter-style application. That is to say, it's a micro-blogging platform. So we'll have users, and we'll give those users an associated data structure called a micro-post. We'll start, as in the last lesson, by creating a new application. This time we're going to call it Demo App. And as in the last lesson, you can see that Bundler is running here at the bottom. Also, as in the last lesson, we're going to open up the gem file and paste in the gem file from the Ruby on Rails tutorial book. So let's take a look at this. As I mentioned in the last lesson, you should use the version on the website, not the one I happen to paste in here, because these version numbers might have changed. Alright, and we can run bundler again. Do bundle or bundle install. I'll just type bundle for now. If you get an error message at this point, you probably want to run bundler with an option. Now, I happen to have all the right software on my machine so that I can just type bundle, but that step might fail for you, so if that happens, you want to do this. Do bundle install, and then without production. This will suppress the installation of the gems that are only needed in production. All right, as per usual, I want to make a GitHub repository, so let's go here. This is the page for new GitHub repository, so let's type in demo app. Repetition is an underappreciated tool for learning. We're doing the same thing we did in the last lesson. I'm going to git remote add. Oh, why didn't that work? Oh, you know what? We need to do. Let's look at our git ignore file. And I want to add this .ds store. You don't have to do this unless you're on a Mac. Git add dot, and then let's commit it. There we go. And so now the git remote add should work. Here we go. And we can do git push -u origin master. Take a look here, continue when you're done. Good. So as before, we have this useless README file. I encourage you as an exercise to change that the same way we did in the last lesson. But for now, I'm going to move on to the data model that we're going to be implementing in this lesson. Let's take a look at our proposed data model. This is an important part of any web application, is to figure out exactly what the objects are in the application. So for the purposes of this demo app, we're going to have users. Let's take a look at this. We're going to have users like this that users will have an ID, which will be an integer, a name, which is a string, and an email address, which is also a string. And then we're going to have microposts. Let's take a look at that. Microposts also have an ID, which is an integer. They'll have content, which is a string, and then we want to identify which micropost belongs to which user, so there's going to be a user ID of type integer corresponding to the user. One of the key challenges of web application development is figuring out the right data model for the problem domain, and then translating that data model into code. So let's get started with that. We'll start with the user data model, which we'll call in this context the user's resource. We're going to be thinking of users as things that can be created and modified through the web. And in the parlance of Rails data modeling, this is called a resource. So there is a model underlying the resource, and then, as we'll see later on in this lesson, there's a controller that controls access to that model. This is where the magic comes in. We're going to create what's called a scaffold using the Rails generate command. What this is going to do is generate a bunch of code. So we're going to create a scaffold for users, which in this case, unfortunately, is singular. It's a scaffold user, and then we're going to give the data model right here on the command line. We're going to say that the name is a string, and the email is also a string. This just created a bunch of code. I encourage you not to look at the code because it's just going to confuse you at this stage. And if it doesn't confuse you, then you're probably too advanced for this tutorial, or at the very least you should skip to lesson 3. So having created this scaffold, we need to tell the database about our data model. Again, you should not at this point be even remotely able to guess what these commands are. You're just going to have to take this tour on faith for now. There's a technique called bundle exec. This executes commands within the context of the gems installed by Bundler. It's kind of annoying that you have to type bundle exec, and there's a setup screencast. It's an installation and configuration screencast that will tell you how to get past this. If you look in chapter 3 of the Rails tutorial book, there's a section on advanced configuration. It tells you how to get rid of this. But for now, we're going to type bundle exec, and then we're going to use a command called rake, and then we're going to migrate the database. So a migration is a way that you change the database, and here we prefix migrate with db. Having executed the migration, we can now start the server. Let's go to the other tab here. S is an alias for server. You can type just Rails S. And we can go to localhost 3000. It's the same about your application's environment. This welcome aboard, you're writing Ruby on Rails that we saw in the last lesson. That might not be too exciting, so let's take a look at a different URL. This is localhost 3000/users. So look at that. We actually have something on this page. It says listing users, name, and email. So let's take a look at what we've done here with this scaffolding command. Let's click on new user. Let's put in a name, and email. Incidentally, example.com is actually reserved for this purpose. This is always pretty cool, I think. Yeah. So you're not allowed to actually have anything at example.com. It's part of the structure of the web. Example.org as well. So Michael Hartle here, name, email, michael@example.com. Let's create user. This is actually working. Like, this is miraculous. Actually, let's go back and see this. You can see the URL here. This is /users/new. This is a standard URL in Rails. Here's /users/1. So you might be able to guess that this 1 here represents the ID of the user. So you can go back here. So you can see we've got a name, an email address, and the ID, which is an integer, just appears here in the URL. We can also edit a user. You can see the URL here, /user/1/edit. So let's change the email address to example.org. There we go. And let's go back, and we can see here's a listing of all the users. And we can make a new user. Again, /user/new. So the name is foobar, example, or the email address is foo.bar@example.com. And we can go back to, and now we can see that the listing shows multiple users. Let's make one more. See if you can guess what's coming. There's a list of so-called metasyntactic variables. Foo and bar are universal. Baz is near universal as the next one. And then quux is their local regional variant on this one. All right, there we go. And now we can see that we've got all these users. So now we've shown how you can create a new user. There's a complementary procedure, which is to destroy one. Let's destroy foobar here. Click on destroy, and we get an alert that says, "Are you sure?" And yes, we are. And now you can see that the user has disappeared. All right, so that gives us an overview of what our little scaffolded application can do. Let's take a look at some code to start getting some insight into what's actually going on. Let's start with the file called the routes file that Rails uses to set up the correspondence between these URLs, like /users, and the underlying source code. So actually, let me show this little sidebar here. This shows the structure of the Rails application. As you get more familiar with Rails applications, I think you'll find that you'll stop using this. But for now, let me just show you where the files are. So this routes file we're looking for is in the config directory for its configuration. So it's config routes.rb. Right, so we need to return. There we go. I just double clicked it there. And I'm going to move it over here. Let's take a look at this file. There's a bunch of stuff that's commented out. This is the Ruby comment character, and the syntax highlighting here is a hint that it's not doing anything. There's this line at the top that just sets up the routes. I don't even really know what this does, so don't worry about this line. But this line is the key of this correspondence between URLs and source code. This is resources users. This sets up a bunch of correspondences between these URLs and the source code. So let's take a look at the source code first, and then we'll look at the correspondences. Let's look at app. This is app controllers users controller.rb. Let's move this over here so we can see it in parallel. So there's a lot of code here. This is all generated by that scaffold command that we ran at the beginning of the lesson. For the purposes of this discussion, we're going to focus on this line here. Don't worry about anything else. In fact, we won't even be using this kind of stuff in this tutorial, at least not until the very end. But this line is important. This @users equals user.all. We're going to take a look at one more file here. It's what's called the view, views, users, and you might guess from this index here that we're going to look at this index here. Don't worry about the names of these files. We'll be explaining all of this later on in this series. So this is an index. If you're familiar with HTML, as you may very well be, this looks just like HTML, except then there's some stuff here that indicates that things are being generated on the fly. So this is a dynamic web page. And now we're in a position to get some sense of what's going on when we hit this URL, this /users. So let's take a look at a diagram. This is a diagram of the so-called MVC pattern, or model view controller, that Rails uses for structuring web applications. And now we're in a position to at least have some sense of what's going on when we hit this /users URL. So we go in with the browser and we hit /users. And what happens is we hit the Rails router, which is this file here. We hit the router, routes.rb. And this line here sets up a table of correspondences that we'll look at in a moment. But one of the correspondences is that the router says that /users corresponds to the index action. And that is this line here in the users controller. So that's step 2. Step 3 over here is to talk to the model file. So let's take a look at that. The model file is under model app models user.rb. So this is a mostly empty file. This line here might not appear unless you're using a version of Rails later than 3.2.3. This was actually added in 3.2.3. Anything earlier than that, and this will not appear. But don't worry about any of this right now. The point is that there is a file called user.rb that corresponds to the user model. And this file is what's in charge of communicating with the database. So if you look at this line here, this line creates a variable called @users. It's a special kind of variable called an instance variable. We'll talk more about it in a couple lessons. But the @ means that it's an instance variable. And it's set equal to user.all. So user here is the user model. And all is a method on the user model that returns all of the users in the database. In our diagram, that corresponds to steps 3, 4, and 5. So step 3 is the call to user.all. Step 4 is the communication with the database. And step 5 is the returning of this list of users, user.all, to the controller where it's assigned to the variable @users. One of the things that distinguishes these instance variables in the context of Rails is that they are available in the views. So let's take a look at that view again. You can see here @users. This is a special Ruby method now on this list called each. So what this does here is it goes through each of the users in turn and returns what in this case a table row for that particular user. So if you look at this very carefully and then look back at the browser, you can probably see the correspondence between these two things. Of course, we saw in that tour of this little scaffolded application that there's a lot more than just /users. So let's take a look at the full table. This is a full table now of all of the different URLs and the corresponding actions. So we have /users. We saw /user/1. That maps to show in here. And you can just go down the URLs and figure out the correspondence. In fact, you can see that the scaffold generator actually tells us the URL. So this is /users here, /users/1. There's also /user/new for the new action. And then there's this strange occurrence here. There's a URL that's /users, but the action is not index, it's create. So you might wonder what's going on there, because we have two URLs that are exactly the same. We've got /users and /users here. The difference is that there are different kinds of HTTP requests. So HTTP is the hypertext transfer protocol used by things that live on the web and communicate with each other. And there are different kinds of requests possible. One of them is a GET request, which is the kind of request that a browser issues when you just click on a link. /users, /users/1, /users/new, and then the edit page, users1 edit. A POST request is a different kind of request. It's the kind of request that you issue in a browser when you click on a form submission. And in this case, when the Rails router sees the /users URL, but as a POST request, it routes it to the create action instead of the index action. And moving further down, there you can see that there are two more requests. There's the put request and the delete request. This is actually going to change in Rails 4, but for now, put is used to update resources, like the user's resource here, and delete is used to destroy the resource. if you just look down this file, you can see that the URLs correspond to particular actions once you take into account what the HTTP request type is. So these 7 standard actions here, index, show, new, create, edit, update, and destroy, are the REST architecture as implemented inside of Rails. The term REST comes from a PhD dissertation by a man named Roy Fielding. It stands for Representational State Transfer. I don't really understand exactly what that means. What I do understand is that in the context of a Rails application, these actions give us a standard way of structuring resources. And this was a big step forward when it first came out. I remember it well because I wrote a Rails tutorial book called Railspace that didn't use this way of structuring applications, at least not until the last couple chapters. And what happened is the whole book went out of date like almost right away. But this will not go out of date. This is a very standard structure. Like I said, that there's going to be a change in Rails 4 with one of these request types, but the basic structure of the URLs and the corresponding actions is quite stable, and it's a really nice way of structuring applications. Oftentimes you can figure out the data model just by saying, okay, which resources am I going to be creating and updating in the context of this application? And we'll apply that strategy later on in this tutorial. This brings us to the end of the user's resource, at least at this point in the tutorial. I'd like to make a couple comments about what we've accomplished. We've done quite a lot here. We've created this web application. It doesn't do very much, but in fact we can create new users and we can edit them and destroy them. But there are a lot of things missing here. There's one thing just right off the bat. If you notice this here, we're not validating the data. So for example, it would be nice to restrict the user data to say require some sort of non-blank name. It would also be nice to require some specific format on the email address, but if you do this, look at that. Nope. Just created a blank name and a blank email address. So it would be really nice to enforce some sort of structure on our data. You also might notice that no one would ever mistake this for a real sort of login and authentication system. There's no way of signing in here or signing out. We also haven't written any tests. And one of the things we'll be emphasizing in this tutorial is a technique called test-driven development, which we'll start in the next lesson. You also might notice that there's simply no consistent styling or navigation. No one would ever mistake this for a real website. And finally, we don't really have any understanding of what's going on. I've talked about this diagram. We've looked at some code, but unless you've done a lot of Rails development already, this is just overwhelming. I mean, there's so much going on here. We'll start remedying that defect starting in the next lesson. Having taken a look at the user's resource, we're now ready to create the second resource for our demo app, which is the micropost resource. Let's review what the model looks like. So here's the micropost model. Remember, we have an ID, which is an integer, a content, a field, which is a string, and then a user ID, which is also an integer. So let's take a look at our generator here. Where we Rails generate scaffold, and then it's the singular version of the resource, which is micropost in this case, and we want a content, which is a string, and user ID. I'm going to put a backslash here to continue to the second line, which is an integer. One thing you might notice is that I haven't included the ID itself on the command line. That gets included automatically by Rails. Incidentally, if you're going to create something that isn't a micropost, it's something that's a little longer, you want to use something other than string. There's a text data type that would be used for a real full-size post, say in a real blog engine. But for microblogs, this is perfectly good. Strings are big enough to hold what we're going to put in them. All right, so that created a bunch of code, and now let's update the database. Remember, we do this with bundle exec rake db migrate. We'll be covering these commands over and over again throughout the tutorial, so don't worry if they haven't stuck yet. Now let's take a look at the routes file again. Remember where that is. It's in it's under the demo app. It's in config routes.rb. Let's put it over here. So notice what happened here. When we made that scaffold, it added a line, resources microposts. So before we had resources users, now we have resources microposts. Let's take another look at those users routes. We can take a look at the micropost routes too. So if you compare these two tables, you can see that the structure is essentially identical. That we've got the same 7 actions: index, show, new, create, edit, update, and destroy. And the URLs are identical, except instead of users, we have microposts. So let's take a look at what that actually means in the browser. See if you can guess the URL. Well, /users is for the users resource. /microposts is for microposts. Let's take a look at the actual microposts controller. So it's under app controllers. Instead of users controller, now we look at the micropost controller. We can actually look at them both. Let's look at them both. If we flip back and forth between them, you can see that they're basically the same, except instead of users, we have microposts. Of course, it won't always be the case that the controllers for different resources are identical, as we'll see later in this tutorial. But for now, it's nice to see that we've got this parallel structure. Before actually going through this this micropost resource in the browser, I want to add something to the structure of microposts, because they're called microposts. What that means is that because they're part of a micro blog engine, we want to control the length of these microposts. So right now, if we were to make a new micropost, we could create it with any amount of length. So what we're going to do at this point is add what's called a data validation to the microposts. That happens in the model. It's under app models micropost.rb. Again, don't worry about this line. We'll be talking more about this later on in the tutorial. This is a very important line, but it's not important right now. Right, what we're going to do here is put in a data validation. We're going to say that this model validates its content, and it's going to set a maximum on the length. Don't worry about this syntax right now. We'll be covering this syntax in lesson 4, where we'll be discussing a lot more about the Ruby language itself. All right, let's take a look at the consequences of that. Let's put in a long string. In fact, let's put in a really long string. I'm going to just grab a long string here. This is what's called a tab trigger. I'm going to type lorem and get a whole bunch of lorem ipsum text. You can read about lorem ipsum in the Rails tutorial book. So I'm going to paste this in, and it's definitely more than 140 characters. I'm going to create the micropost. And we see here that we got an error. One error prohibited this micropost from being saved. Content is too long. So let's make that content shorter. And there we go. We created a new micropost. Now, you might notice that the user here is empty. That's another validation that we would want to make in general. And as we'll see with the sample app, that is in fact something that we'll enforce. One of the reasons we want to enforce that aspect of the data model, why we'll actually want all microposts to have users, is that we're going to be creating an association between users and microposts. Let's take a look at what that entails. This is a diagram of the association that we want to create between users and microposts. This is, here on the right, an example of the kind of data you might have in the database. You've got an ID that is 1 for the first entry, 2 for the second, and then you've got the name and the email. And you can see over here on the left that the micropost resource, or in this case the micropost model, has this user ID, and the user ID for the first and second posts is 1. That means that the first user here has 2 microposts, and then the second user has 1 micropost. So this user ID field identifies which user the micropost belongs to. So let's see how to set up that association in code. We want to look at the micropost model, microposts belong to users. So micropost belongs to user, singular here, belongs to the user model. And then look at the user model. There's a special Rails function here, has many microposts. And this should be quite mysterious at this point, but let's put this in and see what happens. All right, we've created that association. Now let's go back to the browser and create another micropost, but that actually has the right information for constructing this association. All right, we got a writing it. So there was a typo there. Belongs to. Good. Very good. So you can see the error there told us that there was something wrong in our code, which we were able to track down. Okay, so let's take a look at this content. And the user, let's put in user 1. Create micropost. Now, in a real web application, you would want to have a web page to display this association, to have, say, a list of all the microposts for a particular user. And we're going to get to that for sure. That's going to happen later on in the tutorial. But for now, we're going to take a look at what just happened by looking at what's called the Rails console. So the Rails console is essentially a command line for interacting with the Rails application. It's really useful. We can run it by typing Rails console. By the way, this prompt is a custom prompt. You'll probably see something that identifies your particular version of Ruby, but since Ruby versions will vary, I've chosen to use a prompt that's independent of the version. All right, let's take a look at our data inside the database. This is something that we can do right at the console. I'm going to define a variable called first user, an underscore, and I'm going to use this the user model. And the user model comes with it's called a method, in this case called first. We saw before over here in the user's controller that you can do user.all. In fact, let's do that. Let's do user.first right now. Let's do user.all. By the way, you can see that the console tells us what it's returning. It's returning this this user. It also gives you this line. This is the actual SQL that's being executed. So SQL is the structured query language understood by relational databases. And it's really nice that the Rails console tells you what the actual query is. So in this case, user.all. Well, as you can see here, select users.star from users, limit 1. So it's actually just finding the first one. The limit 1 finds the first element in the database. We'll be covering all of this a lot more later on. So user.all selects all of the users, users.star from users, and so on. In this case, I just display the results here in the console, but in the first line, we actually bound it to a variable, so first user has that value. Let's take a look. Right, there it is. Now we're going to see what this association got us. Let's take a look. Here, the micropost. Micropost belongs to user. User has many microposts. So what this association does is it gives us a way to say to a particular user, hey, what are all your microposts? So we can go to the console here and type first user dot microposts. So this is actually a method on the first user object. There we go. It actually pulled out the micropost with content foo bar baz quux, which is in fact what we entered. The console is a great way to learn about Rails data modeling in particular. We'll be using this in a later lesson when we talk about modeling users. But for now, if you want to play around, this is just a demo app. You can't really do too much harm, so you can do things like this. First app.name. Oops, not first app, the first user. .name, .email, and so on. By the way, in order to get out of the console, you can either type exit or Control D. So let's just do the one that will work across platforms. Control D probably works everywhere too. There we go. As a last subject, I'd like to talk a little bit about the inheritance hierarchies that we've seen very briefly in this lesson. This section is only for people who have a prior exposure to object-oriented programming. If you don't have such an experience, you can go ahead and take a look at this, and maybe you can infer from the diagrams and from the discussion what's going on. But this is intended for an audience that has a little more experience. It won't do any harm to watch it, you just might be a little confused. All right, so let's take a look at the user class. Let's go to App, Models, User. Now if we look at this, we notice that there's this first line, a class, user, and then there's this less than sign. This is the Ruby symbol for inheritance. And so what this line says is that user inherits from active record base. Now active record is the library that Rails uses by default to talk to databases, and in particular it's what's called an object relational mapping. It maps objects to database tables, or database table rows, essentially. It's a mapping between objects and a relational database. We'll talk a lot more about the underlying database in the lesson on modeling users, but for now I want to talk about this inheritance hierarchy. So we've got a user inherits from active record base, and we can also look at micropost. Take a look at it. Oops. Here's the micropost model. You can compare them side by side here, and you can see that they both inherit from active record base. And so in the language of object-oriented class hierarchies, both of these would then inherit from active record base. Let's take a look at the diagram. So here's a diagram. Active record base is the base class, and then user and micropost both inherit from it. Similarly, if we look at the controllers in our application, we'll see a similar kind of hierarchy. Let's take a look at these guys. You see there are actually three controllers. There's the user's controller that we created, the micropost controller, and then there's an application controller that comes as part of every Rails application. Let's take a look at this. You can see over here that application controller inherits from action controller base, whereas the micropost controller and the user's controller both inherit from application controller. This is useful because oftentimes you'll want some functionality shared across all controllers. In this case, there is actually a default method called protect from forgery that does some security enforcement. And in this case, that security gets applied automatically to all the controllers. So let's take a look at the diagram for that. And here's the diagram for the controller inheritance. There's a base class action controller base, then from inheriting from that is application controller, and then the user's controller and the micropost controller both inherit from that. The virtue of inheritance is that it allows you to collect a bunch of shared functionality and then share it among a bunch of different objects. In this case, user's controller and micropost controller are automatically endowed with a whole bunch of different functions from the application controller, which inherits from action controller base, and similarly things like the all method that we use with user.all, or the first method that we use in the console with user.first, that comes from from active record base. So micropost also gets all of that stuff for free. That concludes our discussion of the demo app. Let's clean up our repository here. If you do git status, you can see that there's a bunch of stuff. We haven't really done anything since the initialization. So let's just add everything. Ordinarily, of course, if you're doing an application development for real, you should make commits more often than this. But for the purposes of these screencasts, I'm just going to make a few of these commits. So add everything. Do a git push, pushes it up to GitHub. You can visit the demo app page at GitHub. Here we are. And as a final step, I'm going to deploy this thing to Heroku. This is optional, but I think it's really exciting that even at this early stage, we're going to have a database-backed web application on the live web. You may recall from the last lesson how we did this. Let's take a look at it now. Since we've already put our source code under version control, we're ready to go with Heroku. All we need to do is create an application for on the Heroku server. So let's do Heroku create. We'll use the Cedar stack. And that's automatically configured our local repository with Heroku as a remote. So we can do git push Heroku master. I'm going to copy this URL here. All right, let's take a look at that URL. This is the default page. Let's go to /users. See if you can guess what's going to happen here. We're sorry, but something went wrong. So this is expected behavior. Let's take a look. There's a special command called Heroku logs that lets us see what went wrong. All right, looking through this, you can see that there's something here. It says active record statement invalid. So even at this early stage, it's a good idea to start learning how to read these error messages. It says PG error, relation users does not exist. So that's a hint that the Heroku database doesn't know about our data model, which isn't surprising. If you recall, we ran the database migration on our local machine. We have to do the same thing on the Heroku server in order to tell it about our data model. The way to do that is to run rake dbmigrate at Heroku, and the way you do that is Heroku run rake dbmigrate. Now you may notice a couple of deprecation warnings here. I hope that will be gone by the time you see this, but if it's still there, don't worry about it. It's complaining about a directory called vendor plugins that has been deprecated, but if you look at vendor plugins, in fact, there's nothing there. So that's kind of annoying, but don't worry about that deprecation warning. This Heroku rake dbmigrate or Heroku run rake dbmigrate works just fine, as we can verify by going back to our browser. Let's take a look here and just reload this. And there we go. This is running on the live web. This is not on our local machine. This is at Floating Mist, in my case, Floating Mist 5084.herokuapp.com. If you click on New User, look at this. Go back. We can create a micropost. And you can give it the user 1, create micropost. Go to /users. So we can do all the things that we did on our local machine, except now on the live web. And this is a huge step forward from even a few years ago, where it was just such a pain to configure a database, even locally and certainly on a remote server. But by using a very nice lightweight database we'll be talking about in a future lesson called SQLite locally, and using a database called PostgreSQL automatically at Heroku, we're able to defer all of those questions until much later. Eventually, if you're going to be running a production website, you have to know more about your database. So for example, it's a good idea to use the exact same database and database configuration in development as you do in your deployed application. But for the purposes of learning database-backed web development, you don't have to worry about that at this early stage. It's really nice that we can skip all that. So this is really an incredible achievement that we've made here. That we've developed this demonstration application that uses an actual database to persist data, in this case the name and email address of users and other information about microposts. And then it uses that information from the database to construct these dynamic web pages. We've also, in the process of going through this lesson, seen a high-level overview of how Rails works in terms of the structure of the URLs, the model view controller pattern, and the REST architecture. Of course, this is not a real web application. I mean, it's real in the sense that it's actually persisting data to a database, but no one would ever mistake this for an actual website. So throughout the rest of this tutorial, we're going to fix all of the weaknesses in this demo app, and we'll make, in the process, a minimalist clone of Twitter. We'll make an actual microblog engine with users who can sign in, sign out, who can create microposts, and who can follow other users in order to create a feed of their microposts. Along the way, we'll learn about a bunch of other technologies associated with web development, including HTML, CSS, and JavaScript. And we'll also learn a lot more about the underlying Ruby language in which Rails is written. And we'll also learn about the testing framework called RSpec that we'll be using throughout the rest of the tutorial.